Hey guys, Mr. Gran, 6.3 day 1, synthetic division. So we're going to be dividing polynomials. We're starting out with sort of the simple ones, and then we're working towards the more complicated ones. So today's stuff is going to be sort of a shortcut for the more basic form of division, and we'll learn about that and sort of the steps. It's something that once you practice it a little bit, the steps aren't that tough, but it's really, being able to repeat these steps is what we're really looking for here. All right, so we can divide through synthetic division as our first learning target, and then rewriting the quotient in standard form. So here we go. So what is division? It's a shortcut to long division. We'll cover long division in tomorrow's lesson, but this is a special case. It only works when we're dividing by binomials of the form x plus or minus a. So x plus or minus a particular number, just one number. So what that looks like is this. I've got a polynomial, and I'm dividing by this fairly simple binomial, just x minus 3. Okay, so the steps. Get ready to focus, pause as needed to get yourself caught up, and rewatch if need be. First thing that I'm going to do, I'm going to make a little corner here to put a number into, and that number is going to come from this. What we're going to do with that number is first we're going to change the sign, and then we're going to take that number and we're going to plug it in right there. So that is going to become a positive 3. The next numbers are going to be the coefficients from this polynomial. So first thing, it's x squared. Remember that if there's no number in front of it, that has a coefficient of 1. That number is going to go next on the outside of this box. So there is a positive 1. Then our 5 is going to be the next number. And our final number will be, because it's a minus 28, this will be a negative 28. All right, now if you're doing this in notebook paper, leave this line blank, and then make a line at the bottom of it. So you've got a space here where you can write some more numbers. All right, what's going to happen here? This first number, the positive 1, we're always going to take that and drop it straight down underneath. That number doesn't change. What we do next is take this 1 and multiply it by this 3. So this positive 3 is going to be our multiplier. All right, so 1, and we can maybe write a little times 3, is equal to 3. I'm going to erase that, because the next thing we're going to do is add these two numbers together to get the number underneath it. So now we're doing 5 plus 3, and we get an 8. Now I'm going to take that multiplier, and I'm going to multiply again, so 8 times 3. And I'm multiplying by this number, not by this number. I know they're both positive 3s, but it's always this number you're multiplying by. And we get a 24. Then we'll add negative 28 plus 24 is negative 4. And this number, the very last one underneath here, also gets a little box around it because that's special. That is our remainder. All right, so now we did all the math part. Now it's just rewriting the answer. All right, so the way this works, these are coefficients of our new polynomial. Now, essentially what we've done is we've divided x squared by x. We've divided all of these things by x, right? This 1 represented the coefficient of x squared in this polynomial. Well, now if we divided that by x, if you divide x squared by x, you get x. It goes down by 1 power. So this 1 is the coefficient of x now instead of x squared. This 5, that was the coefficient for x to the first power. When you divide x by x, it cancels out and it goes away. So there's no x with the 8. And now this number didn't have an x at all with it. So if I divide that by x, it's over x, right? And so that's what we're going to do with our remainder. Here's how this will look. All right, our first term is 1 times x, which is just x. The next term is a positive 8, so it'll be x plus 8. And then this remainder, it's negative 4 over x minus 3. And so that last number in the little box always goes on top of a fraction, and the bottom of the fraction is your divisor. All right, so that may seem a little confusing at first, but follow along with the next couple, and the more you practice this, this is actually something that most students find relatively simple once they get enough practice with it so that they remember the steps. Okay. So this one's got a little trick to it, so I want you guys to follow along while I set it up, and then once I set it up, maybe pause the video and see if you can finish the problem and then resume when you're ready. Now the trick with this one is this polynomial is not in standard form, so we need to rewrite this in standard form. That's one of the tricks. So x to the 4th plus 2x cubed minus 3x minus 6. And we need to divide by still x minus 2. All right, so first step, I'm going to change this to a positive 2. The reason for that is we're actually looking for the number. If I plugged it in for x, it would make this 0. That's why it's a positive 2. Coefficient of x to the 4th is 1. The next power, x cubed, is 2. Now notice that I skip a power. I go from x cubed to just x. There's no x squared there. That's important. I need to have a number to represent every power of x that's lower than the highest, than the degree. So if I don't have an x squared, I need to have a 0 there. It's kind of as a placeholder for the place of the x squared. Okay, the next one is this minus 3. And our last one is minus 6. So now that it's set up, go ahead and pause and see if you can go through the steps and do this one correctly. Okay, so the 1 always, or whatever number is first, always just moves down here. Then we're always multiplying by this 2. Doesn't matter that that's a 2. This is the 2 we're multiplying by. So 1 times 2 is 2. Now we're adding vertically. 2 plus 2 is 4. 4 times 2 is 8. Now we're adding. So 0 plus 8 is 8 times 2 is 16. This 8 times 2, not this 8. It could be confusing the way I'm writing it. Negative 3 plus 16 is positive 13. 13 times 2 is 26. And then now if we add, our remainder is a positive 20. All right, to finish this off, remember that if I divide x to the 4th by x, I get x cubed. So all of these coefficients just go down by 1 power of x. And the easiest way, I think, to think of this is, okay, if this was x to the 4th, now my first one is going to be x cubed, so it's 1 times x cubed. And then the rest of them are just 1 power down. So if this is cubed, the next one for the 4 is going to be squared. The next one is just going to be x. The next one is going to be just a number, right? So the one before the remainder is always your constant, so no x with that. And then that remainder always is the top of the fraction, and that is the bottom. Like that. And there is our depressed polynomial, is what you call that when you divide a polynomial. And that's your answer, is the depressed polynomial. Probably because dividing polynomials is such a depressing topic. Okay. All right, last one. Now this one's in order, but notice that it's, again, missing a power of x between x cubed and 3x, so there's going to have to be a 0 there. Let's pause and see if we can do this one on our own. All right, so working on this one, that -3 changes to a +3. Coefficient of x to the 4th is 1. X cubed is -2. No x squared, so there's a 0. Then 3 for x and 1 for the constant. Like that. The 1 goes straight down. 1 times 3, right? We're always coming back to this number to multiply to get the one that goes here. So 1 times 3 is 3. -2 plus 3 is 1. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. And 3 plus 9 is 12. 3 times 12 is 36. And that makes 37 for the remainder. All right, if we started with x to the 4th, originally our answer is going to start with x cubed. It goes down by 1, so x cubed. 1 times x cubed, another coefficient of 1, so 1 times x squared, plus 3x, plus 12, plus 37 over x minus 3. All right, so one thing that wasn't in this PowerPoint. Let's say, for example, that we wound up with this, wound up being a -1 for whatever reason. Obviously, it wouldn't in this case, but let's just pretend for this case, and we had a 0 here. So if you have no remainder, then technically, I suppose you could write 0 over x minus 3, and that wouldn't be wrong. But I would ask myself, do I ever put plus 0 at the end of an equation? If that's the case, you just don't even have it on there, because you'll run into a couple of those in the homework. All right, email your teachers if you have any questions, and look for long division tomorrow.